So before we get going, a little bit of housekeeping stuff. So I put up an announcement. I mentioned this last week. Um, there were some known issues with quiz number one. So specifically, there's a handful of questions that the rounding error wasn't set wide enough, the margin of error. So I don't want any rounding issues to cause anything. So I regraded those. I listed the questions that also had some issues. They were edited in time for some of you, not others. And so, once again, I mentioned last week, my mistake is your guys' gain. I ended up giving anyone credit for that as long as they submitted an answer. So you should see those scores now updated and reflected on Canvas. I also went in this morning, so I changed that, remove the lockdown browser, so you should be able to go back and review your submission. But I also wanted you to have a study version that had all those corrections that weren't going to like show up as regraded. So if you want, I think a better way to study for this exam, which is going to be on Thursday, um, is I put up this kind of study version. Let's see here. Go to a preview. So I think it'll look like a usual quiz when you go to take it. So all you'll do is hit start, like you're taking a quiz. And then instead of going through and answering, it's the same questions, just hit submit. All right. Once you hit submit, it should show you what the correct answer should have been. So this is a good kind of one to use as a study tool because all those corrections were made for any of those problems. Also, it allows for kind of rounding issues. So I put that up as well. It's not for any points. It's just a different version of that first quiz that's probably more effective using that one to study as you move forward. I also have put up the practice problems for quiz two. I think we'll get through all of module 4 to here today. If we do, I'll have that set to be released. Now, I would obviously kind of review for that before sitting down to take it. Just like the first quiz, it'll be 60 minutes once you start it, and then have that due date, I believe. Oh, it's not showing up yet. So I have that due date set to be by the end of the day on Wednesday. So not before we start class. Usually I give you 2 days, a little bit more time here. I would suggest getting it done well in advance of that because July 2nd, following day on Thursday, that's going to be the first exam. So you will have a little bit of time to kind of take this one a little bit extra time. So I wanted to mention that. Just a reminder that Canvas discussion, all right, that's set to be due as we go through here. So let's see. So July 1st, also by the end of the day. So once again, you can complete that by the end of the day, Wednesday. I would try to get that out of the way, get that done well in advance so you can start focusing on studying. So you've got that Canvas discussion. You'll have quiz number 2, both due by the end of the day, 11:59 Eastern Standard Time on Wednesday. So I've mentioned this before, but I've had 1 or 2 emails about it. Everything on this Canvas page, everything related to this course is all in Eastern Standard Time. Okay. Other than that, one of the questions that I ended up giving people credit for, anytime you have a drop-down question, if there's more than 4 options, you'll have to scroll down to see all of them. I was assuming that most people are familiar with these Canvas quizzes, but I had someone raise this question. I didn't want that to kind of count negatively against anyone's grade because if the right answer wasn't displayed as the first 4, you might not have realized that there was actually 5 options. So on any of those scroll down or drop down questions, make sure there might be more than 4 options. Make sure you're scrolling to see all of those potential answers. Okay. Other than that, I would say tomorrow, once again, I think we'll get through module 4. So if you have, so we should be just doing a review tomorrow and Wednesday. If you have any questions that you want to see reviewed from the practice problems for quiz 1 or 2, or any of the questions from quiz 1, I can't go through quiz 2 questions because some of the people may not have completed it yet. But if you have questions on practice problems 1 and 2 or that first quiz, if you want to email me prior to class, I will try to throw together and see which questions have the most the most people want to see work through. I can kind of then start with those. I also have some additional problems I think would be good to work through. So the final exam questions, or the midterm exam questions might be a little bit more difficult than some of the quiz questions. So I've got some things I'll work through the next 2 days. So those classes still should be very effective. And I might, wink, wink, go through some questions that don't show up on those quizzes, which will be some good content or good questions to be able to know how to solve. Okay. All right. Any other questions before we kind of dive into material here today? Okay. So, go ahead, just pull that up. Got the Excel file, but the PowerPoint must not have. There we go. So, we left off thinking about growth rates. Okay. So we said, how do I calculate new real GDP? I'm going to take the old GDP times 1 plus the growth rate. But if I'm trying to make projections out for more than 1 year, I need to take that 1 plus the growth rate and raise it to the power of however many years out I want to make this prediction for. Okay. So kind of a review of this. I'll use Excel to be my calculator here. So we had this, we're looking at the importance of growth rates. Let's zoom in a little bit here. Make it easier to follow along with what I'm doing. So let's assume I had a growth rate of 7%. Highlight something that's important here. And the number of years I'm trying to make the prediction for, or N, is 10. And just to kind of make this a little easier, let's say the old real GDP was 100. Okay. So how do I calculate my new real GDP? Well, it's going to be equal to whatever my old GDP was, times 1 plus that growth rate to the power of however many years out I'm trying to make this projection for. Okay. Now, I've got an issue here that we'll talk about, but if I hit enter here, and I could put this in my calculator by just plugging in the actual values, I get an astronomically large value. E to the 11th means move that decimal point 11 places. Well, while higher growth rates do increase old, GDP, not going to be by this amount. So what error did I make? When we use the growth rate in this formula, it's always going to be the decimal form. So if I have a growth rate of 7%, the number I actually should be using, well, if I have it as a percentage, I would divide that by 100. Right? I need to be using that decimal form of the growth rate so I can see here that at a 7% growth, if that's constant over these 10 years, my old GDP would almost double, right? It's almost 200 here. Okay. So make sure we're using that growth rate in decimal form when we're using that formula to calculate our new real GDP. Here's where, don't want to be confusing, but we also have, so we worked through a lot of this last class, but we can calculate these growth rates at different percentages. We did this in Excel. Another kind of nice rule of thumb is how long does it take an economy to double its real GDP? It's going to be 70 over our growth rate, but as a percentage. Okay? So if I want to know the number of years it takes an investment to double, or the number of years it takes GDP to double, I will take 70 and divide it by whatever my growth rate is. So if I think about here, if I have different growth rates, well, 7 divided by 1, it would take 70 years for that to double. 70 over 2, the number of years to double will be 35, et cetera, et cetera. So I can start to answer some questions like, how many years would it take to double my investment, my real GDP to double if the growth rate is 2.5%? And what must the growth rate be if it takes 22 years for my GDP to double? So to highlight this rule of thumb, notice how many years should it take for my investment to double if my growth rate is 7%? Well, that general rule of thumb says 70 over the growth rate in percentage form. Well, we can see here, when we made the calculation, it about doubled in 10 years. Sure enough, that rule of thumb tells me 10 years, my real GDP would double. If instead we're trying to answer those questions, right? If I'm trying to figure out how long would it take my GDP to double if I had a 2.5% growth rate, constant growth rate, well, we can use that general rule of thumb, divide that by 2.5, and we should get it takes about 28 years. I could kind of prove this to myself. I wanted to change these numbers, 0.025, 28. Sure enough, real GDP about doubles. So just keep these, oops. I want to keep these values the same as we had in our earlier example, but that's how I could use my general rule of thumb. Now, if I was told that an investment takes 22 years to double, I could think about how can I figure out what that growth rate would have to be? Well, if I have my general rule of thumb, I know that the number of years it takes to double is equal to 70 divided by whatever that growth rate is as a percentage. So I'm looking for this. I was told it takes 22 years to double. If I just rearrange this equation a little bit, multiply both sides by this growth rate, divide by the number of years it takes to double, I would end up, what is my growth rate as a percentage? Excuse me, 70 over 22, or let's see, this would be what, approximately 3.18%. Or if I want that growth rate in decimal form, and I wanted to prove this to myself using the actual equation, my growth rate in decimal form would just be whatever that growth rate is a percentage divided by 100. So maybe this is like growth rate in decimal form. Okay. Any questions on that before we kind of switch gears to a different topic? Okay. So before we switch gears to another topic, we will kind of take a look at this daily quiz for today. Okay. So if I take a look here, it should be relatively easy based off of what we just talked about. So if I have a real growth rate of 4.8%, what would my real GDP be in 2022 if my old GDP was 215? Well, here I'm only making projection out for 1 year, so this shouldn't be too bad. Right? So here I'm thinking about my general form of this equation is if I want my new GDP, it's equal to my old GDP times 1 plus the growth rate, the number of years. Well, here, right, I think I had my old GDP was, let's see, I'll make sure I get this right, kind of line this up with. So our old GDP was 215. Our growth rate was 4.8%. Now remember, when we're using this formula, we need the growth rate in decimal form. So we would use 0.048. The number of years, we're only make a projection from 2021 to 2022, so it's simply 1 here. So if I go ahead and make this calculation, get this entered into my calculator, I've got what, 215 times 1 plus 0.03, nope, 0.048, right? Raised to the power of 1, that shouldn't change it. I get approximately 225.32. Any questions on that idea before we keep moving? Now, the second question, you should be able to see this, but we can kind of go back, is how many years would it take my GDP to double if the current growth rate is 7%? Okay. Well, our general rule of thumb is the number of years to double is equal to 70 over whatever our growth rate is, but as a percentage. So if I've got a 7% growth rate, it should take 10 years to double. Okay. Any questions on that before we get this submitted? So we had that first one was what, 225.32. And then that second answer should be it takes 10 years approximately to double. Any questions here before we keep moving? Okay. Just to kind of confirm this, if you guys have this pulled in, these are the values that you're seeing for question 1 and 2, correct? Can I get a verification from at least one of you?
Yeah.
Yes.
Okay, just triple checking. So I think the daily quiz on Friday, it was generating different numbers. I had it set to generate different numbers, but I wanted to make sure we're all using the same ones. We're doing these in class. So I just wanted to kind of verify that. Okay, so you can hit submit. You have plenty of time remaining to do this, or if you're watching this after the fact, it should be good. All right, so the next topic we'll talk about is we have these growth rates, right? What is impacting them, right? Or what is causing increases in our real GDP? So we've got kind of POLL is the acronym that we use, but it's really 4 factors, right? And we'll kind of change the O a little bit here just for the sake of this class. So we've got productivity, other resources. Now the other resources we'll focus on is physical capital. I think if you look at the book, it talks about like land as another resource. I won't have any questions of that. The only other resource that we'll really be thinking about is physical capital. So we'll change this O to a K moving forward, right? Representing capital for the rest of the class. Labor is going to be represented by L. This is the number of workers we have in our economy. And then productivity, how effective essentially are our investments into capital and labor. And then we'll also add in this thing a little bit later on, which is human capital, investments made into education or skill level improvements. So with this idea in mind, how would labor and education impact, right, the productivity of our economy? So we're going to call the available labor in this current year T, L subscript T. And this is the number of labor units available. You can think of this as the number of workers available in the current year. So we see changes in labor from year to year. So the way we would define this is kind of what are my, sorry, I had a typo there. So what are my labor inflows in this current year, subtracted by my labor outflows, and then add that to whatever my old kind of initial starting labor was. So here I can think about my new labor will be whatever the old labor was plus inflows minus outflows. What would labor inflows be? Well, it's an increase in the number of workers, the number of employed individuals. What would outflows be? As people leave the labor force or become unemployed, those would be my outflows. Okay? So given the same labor force, right? Excuse me, productivity of my workers matters. So how does the labor force increase productivity? It would be investments into human capital or education. So even if I had the same level of labor, same number of units or same number of workers, those workers become more productive if they increase their skill level, increase their education, or we make investments into labor. Okay? Doesn't have to necessarily be the individuals, right? The government might enact policies that make it more likely people want to improve their education. So maybe giving subsidies, right? Pell grants, all these other policies that the government kind of puts in place. Okay, so we can kind of see here, if I'm looking at GDP per capita and the average years of schooling, and I just plotted the point for every country, and I tried to draw a line of best fit. Well, notice when average years of schooling is low, GDP is relatively low. As we look at countries that have higher levels of education, generally the GDP per capita we see is increasing, and this is real GDP. Right? So the data supports this idea that when we make investments into our labor force or investments into human capital, we generally get larger increases in GDP. So what are these other resources? Well, we're just going to focus on capital for this class. So it could be land, it could be natural resources or raw materials. We're just going to focus on physical capital since it's investments into machinery, production facilities, or new technologies. Okay. So we'll call this K. So changes in physical capital will be whatever the current capital starts out as, plus the investment that we made in the capital this time period, minus the depreciation. So here we're thinking about investments in the capital would increase the level of capital. But as we have different physical capital depreciate, so some of our machines become obsolete, that's going to reduce the level of capital that we have. So, as we make investments, that increases capital, and that should increase real GDP. If we have high levels of depreciation, our old capital is worn out, we're no longer able to use it, that decreases capital and therefore decreases real GDP. So that's why we're subtracting out depreciation there. So aging technology is a good example of this, right? If I have, really old software programs that are no longer really applicable to the kind of current economic conditions, right? I need even better software. Those old software, that the old capital would become obsolete and actually won't, I got this laying around, but it's worth less value. It's going to decrease the amount of physical capital I have available. So with this idea in mind, how do we calculate, given our labor, given our capital, given the investments or inflows and outflows to labor that we have, how do we calculate real GDP? Well, we're going to have a third component, which is we call total factor productivity, or TFP. This is going to be productivity in our economy, right? That makes all resources more productive. So, this could be, instead of labor, or capital, this could be any other component that isn't included in those categories that would cause our workers or our capital to be more effective. So this would be like, even if my labor has higher levels of skill, if I don't have production facilities for them to kind of work in, that's not going to impact my GDP at all. They can't produce anything. So there's going to be some factor. We won't talk too much about how that number is calculated. We'll kind of take it as given, right? But usually it's technology improvements, right? That these just kind of occur. That makes the old level of capital, old machinery I have more effective, and makes my old amount of labor even more effective as well. Another one that's kind of interesting, maybe this is easier to think about how it's not capital or labor, but let's say we have markets that we have increased competition in. Well, we have increased competition, maybe moving from monopoly markets to perfectly competitive markets. Those firms are going to have to try harder to be the firm that everyone wants to buy from. So we will see as competition increases, the same level of capital and labor, those companies are going to try to make sure that they're even more productive because they're competing with other firms. So, electric companies, usually they're like regional or local monopolies. You'll notice even the poles that electric lines are on look like they've been there for 30 years. So that's kind of a good example where competition is actually, there's less competition, that total factor productivity would be lower. So we have a production function that we can use, which includes capital and labor. Now, it also is going to include human capital. We'll hold off on this for a second. We'll just think about physical capital and labor. And once again, natural resources or raw materials will be included in this. For the sake of this class, just to make the math a little bit easier, we're not going to include that either. Right? And then we have some level of overall productivity, or I said you can think about this as technologies, that's going to make each one of those components more or less effective. So real GDP will be some function of these different inputs, and then they will get multiplied by whatever our current level of productivity is. So we're going to focus, right, just on K and L, but the form that we're going to have for this production function is K is going to be raised to a certain power, L times H, for us right now, just L is going to be raised to a certain power, and we're going to ignore natural resources. We could add that in. It's just more components we'd have to keep track of. I want to keep the math a little bit easier here. What is F? So F just represents there's some function, right? And the function that we're going to use is this one right here. In practice, these could be much more complicated than raising each input to a different power. But for us, we're just going to focus on assuming this is the production function. So A is not the current level of output. Remember, real GDP represents the level of output our economy has. That's what we're trying to determine. A here represented the overall level of productivity that we have, or the overall level of technology we're giving our capital and giving our labor. So as the overall technologies increases, the same number of labor and capital would actually produce more output or increase real GDP. Does that answer that question there? I assume. Hopefully it does. Let's make sure. Yep. Okay. So using this production function, let's try to calculate real GDP given the following information. So if I have this production function, we're just going to simplify it to only include capital and labor, and we're told the factor of productivity is currently 20. So how would I do this? Right? So if I'm looking at my per worker production function, I could have it set up like this. And for right now, we're just trying to calculate real GDP. So if my overall level of productivity is A, I'll take that value of 20. I would then multiply that by, and here I have to remind myself, so it was what, 0.3 and 0.5 was the power we were using. So it would be the level of capital to the power of 0.3 times the level of labor to the power of, now I think I forgot, was it 0.5 here? Yes, 0.5. Okay. So this is just, you enter this into your calculator. If you're worried about powers, it shouldn't matter in terms of the order of operations if you order it in this way. But if you're worried about that, and this might come into play a little bit later, I would suggest using parentheses to make sure you're taking capital to 0.3 and then multiplying that by the number of labor to 0.5. If we do that, we get, this will be our level of real GDP. Okay. So I think here, right, we'll save this for a future example, but just to make the point, if total factor productivity increases or we have technology improvements, what happens to real GDP? It increases. Okay. What happens if we have an increase in capital, so our investments in the capital are greater than our depreciation? We see an increase in real GDP. We can produce more than before. What if labor increases? We should see an increase in real GDP. Okay. So we can use this formula, simply input our factor productivity, our amount of capital and current labor, and we can make these calculations for what output of our economy is or what the real GDP is. So we'll come back to this, but I want to kind of highlight some things about this per worker production function that might look similar to things you talked about in B251 if you've taken that course. So if I'm looking here, as I invest more into capital, what amount of output am I seeing, right? We played around with that in the Excel file. We said as capital goes up, I'm going to get more output, right? Or real GDP will increase. Well, if you think about this, when I'm making investments in the capital or giving my workers machinery, what type of capital or machinery am I going to buy first? The ones that are the most important, right? So the first $100 I spend, let's see here, right, should increase my output by quite a bit. Now, the next $100 I invest, so going from 100 to 200, that's still going to increase my output, but the machinery I'm buying second must not have been, hopefully, it wasn't more effective than the one I decided to buy first. It should be, if I'm making optimal decisions, I always invest in what would produce the most output. So the next $100 that I invest, I'm not going from 0 to 450, I'm going from what? Or sorry, 0 to 500. So 500 output increase, I'm going from 500 to 900, only a 400 output increase. So when we think about the marginal output, as I invest more into capital, it's going to be less and less effective capital for my workers, or it's going to be machinery that is less and less important. So my increases in output are going to start to go down, right? Or the change in output is getting lower and lower. Maybe an extreme example of this, if you want to kind of add to those slides. So if I'm thinking about, here's my investments into capital, here's the output or changes, or sorry, the level of real GDP that I'm getting from those investments might look something like this. So initially, that change in output from a specific change in capital is relatively large. But as I make the same amount of investment, so I'm going to try to keep this, all right, the same increase over here. Well, what's happening to my changes in output? Now it's going to be relatively small. Or if I'm thinking about the change in output from a change in capital, what am I really thinking about? I'm thinking about the rate of change, right? Or the marginal output. So my marginal output, as I invest more into capital, well, it's always increasing my output, but it's increasing output or the change or the marginal output. Yes, output's going up, but it's doing so at a decreasing rate, right? Investing more and more into capital, the change in my output is going to be getting smaller, smaller, and smaller. Okay. Any questions on that before we kind of add in another component? And the same would be true if we're making, the same would be true if we're making investments or increasing labor. So what's the next thing we want to think about with these investments in the capital? Or I said it would work the same way with investments into labor. Well, if we have some real GDP functions, so I gave you the functional form earlier where we're taking capital and labor to different powers and then multiplying them by each other. We also had it multiplied by A, our total factor productivity or our total level of technology. So let's assume that technology increases. Well, the same investment in the capital, I'd have the same K put into that function, so this wouldn't change. However, if it gets multiplied by a larger value, now this investment in the capital would produce a higher level of output. So I'm thinking here, if I have total factor productivity or increases in A, that's going to increase my production function at every single level of investment. So at all levels of capital, or I said you could also do this for labor, as we have improving technologies, that same amount of capital or labor will result in higher output. So one way of thinking about this is, if I made that same investment in the capital with higher levels of total factor productivity, or A, I'm multiplying the same value by something that's larger, I'm going to get more output than I was before. So at the same level of capital, when technology or total factor productivity increases, I get more output than I was prior. Another way of thinking about this is, if I want the same level of kind of output here, well, before I had to invest 300 units in the capital, now I only have to invest, it looks like approximately, all right, 150. Okay. So that same idea, it's just kind of looking at this a little bit different. You can say it two ways. When I have technology improvements, the same capital investment is going to lead to higher levels of output if I have total factor productivity that's higher, or if my total factor productivity is higher, to get the same output, I can put less in the capital. Okay. So we're then going to think about what else this total factor productivity will do to my investments in the capital. So we said prior, as I invest more and more into capital, the marginal change, or the marginal output or the change in output is going to be getting lower and lower, right? The slope of this function is decreasing. Now, if I make the same investments into capital, right, or I'm increasing the level of capital along this curve, but I have total factor productivity or technology improvements, right, then we said we can think about this as, okay, the same amount of capital invested is producing more output, but I can also notice something about the slope or the marginal output of these two production functions. When total factor productivity increases, the same level of capital investment is changing my output, or the slope of my output function is going to be a little bit less than it will after the total factor productivity change. Now, I'm going to draw this out. I had this in the slides, but it's kind of hard to see that changed. So I'm going to draw it out more dramatically to really kind of hit this point home, right? So if here's my capital, right? Here's my output. Let's assume that initially, here was my production function, okay? If I'm looking at this level of capital, the slope, right, which would represent the change in my output that's coming from a change in my capital, right? And I can think about this, I could take a derivative of this function and find it at one point, or, if your knowledge about derivatives, you could think about like taking this at an infinitesimally small, amount of change in capital. If I have total factor productivity increase, and here's my new production function, well, that same level of capital, right? Notice what's my slope now? It's significantly higher, or that marginal output from the same level of investment in capital is now greater than it was before. This is a good thing for economists. That means I don't have to change the amount of investments I'm making in the capital, and I'm getting even higher output than I was before. And if I do decide to invest more into capital, that change in output is even larger than it was before. Okay? So the rate at which our output is changing when we have total factor productivity go up, it's going to also increase. So I could think about here, maybe A was 10, and here A is, I don't know, something like 100, right? It caused this dramatic increase in my production function. Any questions on that before we keep moving? Okay. So let's think about if we have the same level of total factor productivity. So I can't like always rely that I'm going to have new technologies. Maybe things are stagnant. How can I increase my economy or increase my real GDP or increase my output? Well, we can make investments into either capital or labor, right? We can increase those, what we call factors of production. Right? It's not total factor productivity, right? That's what either makes our investments into capital or labor more effective. These are the actual factors that we can change. We've already kind of highlighted what we also can see. If we have increases in total factor productivity, we know that economies are going to grow from the previous slide. So I've got an Excel example, and I want to kind of highlight which of these changes are more effective. Okay, so total factor productivity, increases in capital, or increases in labor. So we're going to use that same production function that we had before, k to the power of 0.3, L to the power of 0.5. So I've got what all of these would do on the following slide. But let's kind of go through and think about why that's the case. Okay. So in that Excel file, if I have my per worker production function, well, let's say A goes up by 10%. So these are all going to represent 10% changes for each of these three different categories. So if A goes up, I could think about it as like, what's my new value of A? It would be what? 22. A 10% change would increase it from 20 to 22. So if I put that into my formula, same function I was using before, I take A and multiply it by capital to the 0.3 and labor to the 0.5. Well, if capital and labor don't change, but my total factor of productivity goes up by 10%, right, or goes up to 22, what's the change that I get in my real GDP? So we can calculate those changes in real GDP, because that would just be whatever my new real GDP was after that 10% increase minus whatever the old real GDP was before that 10% increase in my total factor productivity. So it goes up by about 209. Now, what if instead I had the same 10% increase in capital, right? So what would my new value of capital be? What would be the initial starting point, right? Multiplied by 1.1, a 10% increase. So here, capital has now went to 440. If I use that same equation but I don't have a change in total factor productivity. My change is from capital. Now, I could put this formula in 1.1 times 400, or I have down here that $440 value. So if I don't want to kind of put a bunch of functions in here, I want to break this down step by step to just hopefully, prevent myself from making kind of order of operations errors. I could put that value of 440 in here, in which case a 10% in capital would give me a new real GDP of 2150. So what was the change in my real GDP? It's my new GDP minus my old GDP. So notice that increase, that same 10% increase, but in capital, a factor of production, but no change in total factor productivity, doesn't increase my real GDP by as much as if I had a 10% increase in total factor productivity. And then we would go through the same process with labor. Okay? If I saw a 10% increase in labor, so 300 would go up to 330, or I can kind of prove this to myself by making the calculation. I could then take that same production function, no change in my factor productivity, no change in capital, but now I'm seeing a 10% increase in my labor. So again, if I want to break this down into steps, I could just enter in that value of 330. I see that this is my new real GDP. What was the change in GDP? New GDP minus my old GDP. I can see that labor increased my real GDP by more than that 10% capital increase, but less than that 10% increase in total factor productivity. So this really highlights that if we have this production function where we're taking capital and labor to a power that's less than 1, increases the same percentage increase in total factor productivity is going to cause even larger changes in our real GDP. So what do we want to focus on? Probably improving technologies, right? Because even if capital and labor stay the same, increasing that total factor productivity is going to influence our output or our real GDP by more than those capital and labor 10% increases. Okay. Any questions on this idea before we keep moving? Could you go over so yeah. So all I'm doing there is taking whatever my new real GDP was after that 10% increase in capital minus whatever my initial starting real GDP was. And I'll post the completed version of this as well. So Bonnie, this is a very good question, right? You actually anticipated something I wanted to work through. So let's assume we have this exact same thing. Now, what I'm going to do here, I'm just going to copy this over so we don't have to make these calculations by hand. So I'm going to have the exact same values. Okay? So over here, yes, capital, 10% changes in capital cause a lower change in real GDP than a 10% increase in output, or sorry, in labor. So what if instead I had a production function where the functional form was not capital to 0.3, capital to the 0.5, and labor to a lower power? Well, if I have something to a lower power, changes in that should cause lower changes in that real GDP. We could go through and prove this to ourselves, right? So I have that 10% growth, that's going to remain the same. However, now I'm going to take capital to 0.5 and labor to 0.3. I'm going to have to make that adjustment in every single one of these equations. This is where if I put these in a different cell, I could actually even expedite this process, but just to highlight this, we'll kind of do this by hand. So here I've got capital is now essentially more productive than labor. If I now make these calculations, I have kept all the formulas the same. Well, kept total factor productivity, capital, and labor all the same values. So 10% increases. Now notice total factor productivity still wins out, right? A 10% change there produces much higher changes in real GDP than changes in or 10% changes in capital or labor. However, because capital is raised to a higher power, it's actually adding more output than labor, even if those values were exactly the same. And so anytime the power of capital is greater than the power of labor, notice the change now is larger for that 10% increase in capital than a 10% increase in labor. So one way you might be able to kind of summarize this is given the same percentage increase in capital and labor, the change in capital, right, will increase output by more than that change, same percentage change, I should say, percentage change here, than the amount that same percentage increase in labor increases output by, right? Because in that second example, right, we had if K was to the 0.5, labor was to the 0.3, that's going to be the case when the exponent on capital, so this will hold if the exponent on capital is greater than the exponent on labor. And then the exact opposite is true. So that percentage change in capital would increase output by less than that same percentage change in labor would increase output if that exponent on capital is less than the exponent on labor. We saw that play out in the Excel file. This is kind of a nice summary of that. So which of these factors of production are more effective? Essentially, whichever one is being raised to a higher power. I mean, that's just a byproduct of math. So in this case, when capital is being raised to a lower power, capital should be less effective, or that same 10% increased GDP by less than a 10% increase in labor. When we had the exponent on capital being larger than the exponent on labor, now a 10% change in both of them, which one increases output by more? Now it's going to be that same 10% increase in capital. Does that answer your question? Oops. Once again, you kind of anticipated the next thing that I was going to work through. Okay. All right. So, yeah, time here. Oh, we're doing pretty good. So let's say, what if I have the following, right? So this is where it gets a little bit tricky, but we can think about it. This is my production function. What happens to real GDP if total factor productivity increases or is higher, but the investments made into physical capital decreases? So if we don't know the percentage change in each of these, then really what we're left with is our real GDP is going to be A times capital, to some exponent, and then times labor to some other exponent, right? We might be given values here, but just in general. So if I see an increase in total factor productivity, but at the same time, investments into capital go down, I would need to know which one is a relatively larger change, or which of these values would be larger. So here, the answer would be, I can't determine, right? These changes are pushing my real GDP in opposite directions, and so I don't really know what's going to happen to real GDP. Now, what would produce a similar thing? So if we go back and we remember that the current level of capital was the old level of capital plus the investments we made minus depreciation. Okay. So what if instead the investments we made into capital, so we're still investing, but the rate or the amount of depreciation that we have is less than that? Well, what is that going to do, right? If depreciation goes up by more in investment, this value would be less than zero or negative. It's going to decrease capital. It'd be the same that we kind of had before. Right? So decreases in investment or increases in depreciation would cause capital to go down. Okay? In which case we might get, even if these things happen simultaneously, an answer which is we can't determine. Now, sometimes they move in the same direction, in which case we definitely know what's going to happen to real GDP. Okay. Any questions on that idea before we keep moving? Okay. So here we had physical capital decrease. I mean, that could either be that we have decreases in investments in the capital or increases in depreciation. So now we're going to add in a third component, right? So our third component is going to be the same amount of labor would be more or less effective if they have higher levels of human capital or higher levels of education, or their skill levels are increasing, right? It doesn't have to be you learn it in college. Maybe you're just reading about things on your own and kind of learning new skills. So we're going to have the same production that we had before, A times K to the 0.3, but now instead of labor to the 0.5, in these easier examples, we're assuming that human capital is what we call normalized to 1. So that whatever the kind of current level of human capital is, we're just normalizing that to 1. And so anything times 1, we just had labor. However, if we see increases in human capital, what happens to the same amount or the same level investment into capital and labor? What would happen, even total factor productivity, what's going to happen to our real GDP? Well, if we increase human capital, this is going to increase. Real GDP has to increase. So investments into human capital are essentially the same exact effects as increases in our labor. Right? Or you can think about labor as like the number of workers. H is like the productivity of those workers. Right? So if human capital goes up, even having the same number of workers, I'm going to get more output than before. Any questions on this idea? Okay. Let me make sure I've got an example here. I wanted to think about this. So, I mean, we can work through this real quick with the numbers, but it's not, I don't think, anything too crazy. I'll add an additional example that I think maybe highlights the importance of human capital a little bit more here in a second. But if I did have increases in human capital, so it's not normalized to 1, it's 1.5. Okay? If I do that, what would be the new level of output that I get? Well, we could go back to our calculation. So instead now, so if I think about this as a human capital example, let's assume we don't have any of those changes that we had before. We're just working with the initial numbers. So now my real GDP would be whatever my total factor productivity was times whatever my investment or my level of physical capital was to the 0.3, same function we were using before, multiplied by whatever our labor was, but now times that human capital, which is not 1, it's higher, it's 1.5. So this is where order of operations matters, because you don't want to just take 1.5 to that power. You want to take labor times that human capital level of 1.5 to that same 0.5 power. So if we do this, if what I said was true, the same amount of labor and the same amount of capital, the same total factor productivity should increase my real GDP relative to what it was before. Sure enough, it does. Right? And I could then go through even more examples. So let's say I have that same equation, but now I invest more into human capital. Whoops. 2 instead of 1.5, I should get even larger increases in real GDP than before. Now remember, this is using the same amount of labor. It's just that because they have higher levels of education or higher skill levels, they're going to be more effective workers. So this is kind of good news. Like if my population is relatively stagnant, right? Well, as long as I'm investing into human capital or education, I should be able to still see increases in output. In fact, I don't think I have, I know I don't have this in the slides, but I want to work through some numbers here. I'll kind of show you the equation and then we'll kind of work through some numbers. So what is the difference between labor? So if you want to think about this, labor is like the number of workers. Human capital is essentially the education level or skill level of those workers. Yes. So what you said is kind of it's a good way of saying. So if I want to use this total factor productivity, total factor productivity. If I want to use this real GDP function, and I've got total factor productivity times K to the we'll keep using the same values times L times H now to the 0.5. Right? What happens? So in the US currently, the birth rate is below 2. So over time, what's going to happen to the number of workers we have? It's going to decrease. Or what else could decrease labor or the number of workers that we have? Increases in unemployment, right? So tying this to old things we talked about, even if unemployment is high, I see a decrease in the number of workers. What if simultaneously I am investing a large amount into human capital? Well, then it doesn't matter that my labor force is decreasing as long as my human capital investments are enough to compensate for that. I could have fewer workers and still see increases in output. Now, this is bad if I'm the individuals without higher education and I remain unemployed, but for the overall economy, this would be a good thing. The investments in the human capital by the individuals who are remaining employed could actually increase our output or our real GDP. And I could play around with this. So let's say we had this same example. Let's say I had, so remember this represented human capital was increasing. So let's say before I had this real GDP value of 2090, could I still see that even if I have less labor, so let's say we do like 290 here, would this change, right? So I'm seeing labor decrease, but here I'm actually making higher levels of human capital investment, something greater than 1. Well, there we see, okay, as long as I have human capital investments, even though labor went down, I can still see these real GDP increases. And I'm going to put this back to the original values. I just want to kind of add that in. Some more value added in the class than simply looking at this Excel file. Okay. Or sorry, value added of watching this lecture or attending it live. Any other questions? Oops. Before we keep moving. So I went a little bit out of order here. And I gave you some examples already of this. So I gave you an example already about what happens if depreciation is greater than the investments in the capital. We said that would decrease capital and decrease real GDP. So we know that if this is true, we would see a decrease in our overall level of capital, which would decrease real GDP. But what happens if our employment is increasing by more than our unemployment? So remember, we said, there we go. So we said earlier, right, when investments, make sure I have this, so depreciation is greater. Yeah. So if the investments was less than depreciation in the capital, our capital was decreasing. So I'm going to do, since this is a different example, I'm going to have this down here. We had L times H to the 0.5. Okay. So if investments were less than depreciation, that was causing capital to go down. Well, let's assume we also, at the same time, I'm going to try to use colors here. So this is our second example. What if at the same time, so remember, our labor currently, or in the next time period, will be whatever labor was before, plus our labor inflows, or you can think about this as the number of new employed individuals, minus our labor outflows, right? Or we can think of the number of unemployed individuals. So if the number of new employed individuals is greater than unemployed, what would we see? We'd see labor increase, in which case, what's going to happen to real GDP? We don't know. It would depend on the relative size of these changes, but also the relative size of these exponents. So we're not going to dive into the more complicated math of determining which of those is larger. We're just going to say if we have it pushing these factors of production in opposite directions, we can't determine what's going to happen to real GDP. We have less capital than before. We have more labor. Who knows? Just to reiterate a point, though, because I think we're going to have time to finish anything anyways, or everything anyways. What if I saw the same percentage. So let's say I saw the same, that capital and labor start out the same, and I saw the same decrease in capital as I did the increase in labor. What would happen to real GDP there? So if I think about if I had that percentage change in capital, it was the same as that percentage change in labor, and they start out at the same value. What would happen to real GDP? Well, what would we have to look at? Same changes here, they're in opposite directions. What's going to happen to real GDP? Whichever one has the higher exponent. So when that exponent on capital is less than our exponent on labor, well, if I see the same changes in capital and labor, the one that's going to be more kind of add more to my real GDP would be the one that has a higher exponent. So in this case, labor has a higher exponent. It was the one that's increasing. So we know there our real GDP would be increasing. That's, it's probably the most complicated question we can get at, kind of combining all of these. When it gets to the quiz, you're likely going to see me break these down, component by component, but everything we've talked about, we could kind of throw that together. And that would be kind of our answer to that question. All right. So we went through this. Final topic that we'll talk about is different stages of development. So we have these increases in labor, increases in capital, technology, or total factor productivity. It's going to produce different stages of our economy. So we've got kind of the agricultural stage. If we go back in time, or we think about countries currently that have relatively lower levels of GDP, most of them, the majority of their GDP is going to be in agricultural production. Right? How do you exist as a nation? You have to first feed your people, if you want to think about it that way. Also, at lower levels of GDP, what would be causing that? Potentially lower levels of total factor productivity. We don't have high levels of technology. We can't produce computers. We would then kind of see economies as they increase their GDP, move to the manufacturing stage, where we've got enough food to feed our people, our labor force, right, is now secure. We start to see increases in labor. We can now move on to real output increases, start to make investments into technology, improve our technology, our total factor productivity. We now can produce laptops, right? We can start to produce different goods than we were before. And then once we have all these goods, and this is once again, if you look over time, even the US, go back 200 years, the bulk of the GDP was agriculture. Then if you look maybe, 100 years ago, a lot of it we're progressing into manufacturing. And then what do we see kind of currently? Well, we've moved into the services stage, or not currently, but if you go back 20, 30 years, what do we start to see? Well, a lot more, not physical goods, but different services that were being provided. This could, even things like accountants, right? That do your taxes for you. This could be currently like increases in, think about like Uber and Lyft. That's not really an output of services that we're seeing the economy produce. And so we kind of see economies kind of move between these different stages, right, as GDP per capita grows. So with these ideas in mind, let's kind of just look at some actual data. You can kind of see this GDP per capita, and then a measure. So this is, so this is Our World in Data was the source. But they have different measures of what overall GDP is, and they also have what overall levels of output comes from the agricultural sector. If we had to do a line of best fit here, looks like it would be kind of downward sloping, or as we see higher levels of per capita GDP, the percent of that economy that is agriculture starts to decrease. And so this supports kind of this idea of the movements between these three stages. Now, if we look at industry, so this is like the manufacturing stage, it's not quite as clear. It looks like maybe there's like I had a line of best fit. Maybe it'd be something like right here. So it still kind of goes to support that when GDP is low, the percent of our GDP that's manufacturing is also relatively low. And that as we see higher levels of GDP, that manufacturing percentage increases. Now, why are these economies, why does it look like maybe there's a U shape, right? If I had to draw a line of best fit and it didn't just have to be a linear line, it could have some curve to it, right? Or it could be a quadratic function. Well, initially, when I see increases in GDP, I move to that manufacturing stage. Percent of GDP that's manufacturing increases. But we said, what's the third stage? Well, as I see increases, more and more increases in GDP, I start to now not produce manufacturing goods, but more services. So these higher levels of GDP, the percent of my GDP that's manufacturing starts to go down because we now move to providing more services than we were before. Right? So the third stage begins, right, at higher levels of GDP. Oops. And then if we look at the third one, percent of my GDP that's services, notice there at higher levels of GDP, this kind of supports, like I see higher percentages of the economy be from services. So support about this, about these movements between these stages of production. Where are we at on time? Oh, I think we should be good. Well, then let me make sure. So this is an annoying thing, and you guys know this has nothing to do with the class. But my watch and my phone are always 4 minutes fast, and I can't figure out for the life of me why. So I try to keep an eye as best as I can on the computer to have an accurate time to make sure we're done by 12:30. So the last thing that we'll talk about today is, so initially I see movements in these stages of development, right? How is that? What causes that? Maybe I have higher skilled workers, I'm making investments into human capital, or human capital, businesses are making investments into physical capital. What's going to also happen is that as GDP increases, I'm going to see income inequality also increase. So as we start to progress through these stages, there's more social mobility. So eventually, as we have higher levels of GDP, more and more people are able to get higher levels of education. We start to see people to be able to move, right, to higher paying jobs, and we actually see that the change in economic inequality is actually going to go down. Also, as we see higher levels of GDP, there starts to be more government programs that try to redistribute wealth. And so as GDPs grow, we also tend to see more welfare programs, which then decrease economic inequality or improves. So a nice kind of summary of this is what we call the Kuznets curve. So if we were to look at this relationship, as GDP goes up, well, that's always going to cause some level of economic inequality, right? So notice every level of GDP here, economic inequality is above zero. We have some economic inequality. Initial increases in GDP start to increase that economic inequality, but as the GDP grows, it's doing that at a decreasing rate. So initially, improvements in real GDP will cause increases in economic inequality, but those same levels of growth as those same increases in GDP at relatively high levels or higher levels of GDP growth starts to increase income inequality, but at a lower rate. Now, eventually, we start to get the levels of GDP where, once again, social mobility increases. We have more investments in these social programs that redistribute wealth. So once we get past this level of GDP growth or higher levels of GDP, we start to see that economic inequality actually starts to decrease. And not only is it decreasing, as GDP gets larger and larger, it's decreasing at an increasing rate. So this idea that, yes, GDP growth initially can cause some economic inequality, as we see GDP grow more and more, that same GDP growth is going to produce smaller increases in economic inequality, or it's increasing at a decreasing rate. And that eventually, once we probably get from like the manufacturing to the services stage, there, the same GDP growth will start to decrease economic inequality. And as we continue to grow more and more, it's going to not only decrease economic inequality, but decrease it at an increasing rate. So that should kind of do it for module 4. Before we kind of end class, well, yeah, 5 minutes. I want to give you just another way of looking at this just for a second. So when I have that economic inequality, since we have a little bit of time, and I'm thinking about GDP growth. When growth is relatively low, I would kind of see this increase in economic inequality, relatively high decrease. So let's think about it this way. The same increase in GDP growth, so maybe I'm going from 2 to 3%, and then up here, I'm going from, I don't know, we'll do 6 to 7%. That change or that increase in economic inequality is relatively large. But that same 1% increase in growth, once we're looking at higher growth rates, now the change in my economic inequality, it's still going up, but the change is relatively small, right? So the change in economic inequality, relatively small. Compared to at lower levels, it was relatively large. This is the idea that the slope of my function is decreasing. I could also think about it on the other side of things. So let's say I start to see at higher growth rates, maybe this was 12 to 13. And then down here, I could do, trying to keep these like the same here visually. So this is like, I don't know, 20 to 21. Now that same 1% increase in GDP growth at higher levels of GDP growth, notice now it starts to decrease my economic inequality, but that change is relatively small. And then if I'm looking down here at relatively higher levels of GDP growth, that same 1% increase causes a relatively large change compared to before. Okay. So summarizing on the slides, at lower levels of GDP growth, increases in growth start to increase economic inequality, but at a decreasing rate. Once we get to a certain point, increases in GDP growth starts to decrease economic inequality, but at an increasing rate, right? And so this is yet just another reason why economic growth is important, right? Or why these growth rates are important. Okay. Any other questions before we get out of here? So we've covered all the material, so I will post that quiz once I get back to my office, that quiz number 2. It won't be available until after my other sections, so that'll be 3:30 today. I would go through those practice problems as you're studying for that quiz. Other than that, like I said, email me any questions that you want to review tomorrow on any of those sets of practice problems, even for this upcoming quiz. That would help you study for quiz 2. It would also help you study for that exam, which is going to be on Thursday. Another thing I want to mention before we get out of here, that exam on Thursday, I had in the syllabus in the first week of slides is going to be available between 11:15 and 3:30. I'm going to expand that a little bit. Excuse me, I'll actually open it so that it's available anytime between 9:30 and 3:30. So make sure that on Thursday you have a time block, Eastern Standard Time, between 9:30 a.m. and 3:30 p.m. in which you can sit down to take this exam online. Once you start it, you'll have an hour and 15 minutes, usual class time, which means if you want to complete it before that 3:30 deadline, you need to start it by what? 2:15. And I'll mention this again the next 2 days. I just want to kind of get it out there right now. Okay. So that should do it for today. I'll end the recording, and then if you have any questions, you can hang around. I can answer those.